Hello, engineers, and welcome back to the DevSecOps series again. So today we are going to see particular roadmap that beginners can use so that if they want to get into DevSecOps, they would have this roadmap handy of what they need to learn so that they could call themselves as DevSecOps engineers. So welcome back to our channel, and we have a particular mind map today created which would be useful for us. So let's see what is this particular thing. uh, so I'll just show you this mind map, but before that we would just see what we have covered till now. uh, I have just shot one video today, and you will get to see that very shortly. So we have covered till GHS, GitHub Advanced Security, SCA with OWASP dependency check tool, SonarCube for SAST, SCA, and threat modeling is what we have covered. And now we will have a DAST video as well. So after this is what we are going to learn, the roadmap. So here you can see what is what are the different things that you would need to learn to become a DevSecOps engineer. So let's begin it from here. We'll just like expand this one and see what are the different things. Okay, so here we have 12 different stuff we need to learn in order to learn DevSecOps. So what is the first thing? So fundamentals. It covers understanding of the DevOps. So before you learn anything else, you need to get this thing right. So if you do not know DevOps, how could you learn SDLC, and how do you figure out in what phase or which life cycle stage do you need to implement what kind of tool? Okay, so that's why understanding of DevOps is really important. You need to learn first what is CI/CD, what are different operations that we can see in Git, as well as IAC, what is IAC, infrastructure as code, and agile and SDLC concepts are really important for you. If you do not know SDLC, then it is really very hard for you to grasp the concept of SAST, DAST, SCA, and where they are applied, when they are applied. Okay. So better you first get to learn DevOps, then you can move to other knowledge on the other parts. So next is basic security knowledge. You will need to learn about what are the different top 10 vulnerabilities, common attacks that are possible on the application. Now how to defend them, that is also you need to learn. And what is CIA triad? So confidentiality, integrity, and availability. What is the role of all these things in security? So this is what basic security knowledge you need to have. We will in our future videos see what is CIA triad, what is OWASP top 10, what are the different common attacks as well. So this is the very first fundamental stuff that you need to cover. Then you will need to learn about what is source code management, how to do it. Okay, what is a version control system? So uh, it's secure version control. Sorry, version control VCS is what first you need to learn. Either you learn Git, GitHub, GitLab, Bitbucket, or anything else. So that's one. Then how to sign commit. Okay, GPG, using GPG. So this is, I think you can skip for now, but you will of course need to learn about how to protect branches and what are the different tools that you know. The Git leaks and Trufflehog, it would be used for detecting secrets that are there in the GitHub or repositories that you would have in your source code management applications. So then you will need to learn about secure coding practices. You would have few different stuff uh, you know which are mandatory for development purpose. So first of all, you would need to have a training for your development team so that they could know what are the different facets of security. Then you will need to implement input validation or sanitization that we say uh, for each you know uh, text box or description area or wherever you are getting inputs from. So that's why input validation is important. Then authentication is what you need to do, secure authentication for the application related access or API callings using tokens, JWT, and all these different OAuth methods. So authentication is one more thing. Then if there is any error, how do you handle that? This is what you need to have mentioned in your secure coding practices in your application. So this is really important for you to learn. Then what are the different tools that you can use, get this secure coding practices from? So if you integrate SonarCube, SemGrep or linting tools, so bear in mind SAS tool and linting tools are different. So ESLint with security rules is required. SemGrep and SonarCube would check your code base for different standards that are there in your worldwide. So that is about secure coding practices. Then what is SAST? Okay, static application security testing. So we have to check the code base. That's the very first and crucial and the utmost important stuff in an application, the code that developers are writing. So integrate these particular SaaS tools earlier in the CI pipeline, then automate the pull requests or merge requests and check them if they are not kind of failing anything, or if there are any security vulnerabilities in the new code that has been pushed. So you can use these different tools, Sneak code, Checkmarks, Fortify, SonarCube to do that. There are others as well, Vera code. We have you know seen how to integrate SonarCube for SAST in one of our videos. So here you can see SAST with SonarCube is what we have covered already. Okay, so you can go in this particular YouTube playlist that we have and see how to do it. The next is what is SCA, software composition analysis. So you can expand this thing. Now, as opposed to this thing, it SAST detects the vulnerabilities in the code, but SCA would identify vulnerable dependencies. So third-party applications, or not application, libraries or dependencies or modules, if you consume, then it would check for the vulnerable dependencies, and it would check if there are any license compliance met or not met by these tools, and if there is application library that you are using which is not licensed, then by default your application is not complying to any kind of regulatory body. So that's what you can check in the SCA tools. So Sneak is also there, White Source or Mend. White Source is the latest name, and OWASP dependency check is what you can use to test against the software composition analysis. So for OWASP dependency check, we have covered it in this particular videos, SCA with OWASP dependency check tool. You can see how to integrate OWASP dependency check for your application, what configurations you need to add, and how to read the reports that are generated out of it. So you can go and check this particular video. Next is you need to learn about CI/CD security, okay, pipeline security. So you need to see the jobs that run for your application. They run on certain runners, okay, or agents. So you need to first secure these runners. If someone kind of attacks your runners, then your application is by default going to have certain problems or vulnerabilities. So that's why securing your runners is really important. Then secret management is also important. You need to have a vault or secret manager, and what things you can integrate in your pipeline. So you can integrate SAST or SCA tools. Container scanning and DAST is optional, and you can do it as well from the CLI or CI/CD pipelines. So that's one thing. So you can integrate this kind of levels of security measures in your application using CI/CD pipelines. Then what is infrastructure as code security? So as I mentioned, application creation is one method, okay, development of an application. Next is where this application would run. Okay, it would run on certain kind of infrastructure. Now you are not always going to go on the console of AWS and create an infrastructure using manual clicks. You need certain kind of automation for that. So for automating that, we have seen infrastructure as code methods, okay, which would write your code infrastructure as a code, and then once you apply this particular code, then it would provision such kind of infrastructure. So IAC security is really important. So IAC scanning tools for Terraform, Ansible, cloud formations are required. You need to check if there are any loopholes or any misconfigurations that are present in your application. Sorry, not application, but the IAC code. So you can detect misconfiguration before you deploy. the entire infrastructure. So if there is any VPC with the um, by default internet traffic or open traffic allowed, so that would be a huge problem. So you can see Checov, TFSafe, or TerraScan are different tools that you can use. There is one more Kix framework you can use as well. It would scan all the infrastructure as code files. So you can scan the IAC as well using it. So this is one thing. So I hope you got to see SAST, SCA, secure coding practices, SCM management, okay, fundamentals of security, CI/CD pipeline, IAC security. Next is container and image security. So nowadays there is a lot of adoption of Kubernetes and what it say Docker. So you need to have image scanning as well as container security scanning for any kind of vulnerabilities. So build minimal base image. So whenever you write Docker file, there is a base image that you say like from and then the name of the base image. So if you use secure base images, your application, and also if you kind of build any application, so it should be having minimal number of packages, or operating system should be hardened. So that's what minimal base images are for. And then you can scan this image for vulnerabilities. We would see this thing in our later videos, wherein we are going to use aquasec privy, docker scout, or what's this gripe for scanning this particular container or the base images for that matter, and then check what are the different uh, you know uh, vulnerabilities that are found out of it. So aquasec trivy, gripe, Claire is one thing, and docker bench for security, that is another one. So that is container and image security. Now there is one more tool which looks at the running state of this container, so which is sysdig. So sysdig also it has a CLI, and it can show us what are the different findings of a running container are. So that is one thing. Next is dynamic application security testing. So as we have seen in another video, which would appear over here after patch it up, which is about DAST. So and it runs an application in a running state. I mean, it scans an application when it is in running state. So that's one thing, and it focus on runtime behavior. So it would inject malicious code or inputs and check the responses if it behaves in a certain different way. So that's what we see. So OWASP Zap, Bubsuit, or Stackhawk is one tool as well. So we will see the demos of OWASP Zap and Bubsuit in our later videos that I will upload after the dashed video is being uploaded. So stay tuned for that. Then next is runtime and cloud security. So now once application is deployed, you also need to have the security for the cloud infrastructure that you have created, or whatever the server that you are using. So for that we have monitoring, logging, and alerting methodologies used. Okay, we would get who entered the servers, who did what. That is what we need to check. So these are the things that we need to learn. So repudiation is one of the most important thing, wherein someone who kind of did something should not uh, go and tell, okay, I didn't do it. Okay, so that's what repudiation is, to track all the activities of the users and check who did what. Then for runtime protection, we have Falco or Aqua Security, and we have major different tools as well from the vendors, or the different cloud vendors. So AWS would have its own tool, then GCP would have its own Cloud Armor and all these different things. So here you can see for cloud security posture management. This is the topic that we haven't covered yet. So CSPM we are going to cover in later videos, but for now you can see AWS Security Hub, Wiz, or Prisma Cloud are the different method or the tools that we can use for cloud security posture management. So don't bother about this right now, it would be very heavy. But just remember, if you are having certain cloud infrastructure, how safe it is it 100% secure, is it 90% secure, is it 35% or 20% secure? How do we measure that? Okay, so we measure it using this cloud security posture management. We can say by applying these policies, by having this kind of infrastructure, we are 80% secure. So that is what CSPM would stand for. Next is GRC, governance, risk and compliance, is what you will also need to learn. So you can define policies and compliance, regulatory and requirements, all this stuff. You can automate audit reports and traceability of your applications, and you can do it using these tools. Okay, Tugboat Logic, Vanta, Data. So GRC is really vast topic. Okay, we have GDPR, we have NIST framework, security framework. Okay, we have SOC, SOC. Okay, we have FedRAMP, we have FIPS, different kind of compliance regulatories that we can see. Okay, then you have this thing wherein you will need to have a red team versus blue team exercises, wherein red team would attack your application when it is served, and then blue team is the one who would kind of works on the defensive side, who would try to detect it and detect the attack, and try to defend attackers from getting to your sensitive data. So that's what red team and blue team exercises are. Then chaos engineering is majorly done for security. You need to you know create certain moments or events wherein there would be something breaking, okay, for your application or your infrastructure, and that's how you now will check if your application is ready to handle certain chaos. Can it recover quickly from a disaster? Okay, can it replicate its backup or replicates the database? And if that replication is done properly, or it is stored in some different region, and then it is safe. Okay, it is not exposed to the outer world. So that is what chaos engineering means: disaster recovery, and all this different stuff. And you also need to learn about what is CVE, CVSS, EPSS, CWE. You need to learn MITRE attack framework. Okay, you can learn different threat modeling concepts like Stride, Dread, Octave, Pasta, and all these different things. So these are the different learnings that you can do. And of course, sample DevOps, DevSecOps toolchain. You can see over here different stages of the SDLC. So at code stage, what do you do? Okay, this is what you will do. Then at build stage, these are the different tools. Okay, at the test stage, these are the again different tools. You can see release stages, deploy stages. Okay, and monitoring stages, Prometheus, Grafana, and all these Datadog, Splunk. So these are the different tools or tech stack you can see. Uh, if you want to learn all of this, all the best. It's a lot. So that's how we get the holistic view of the roadmap of learning DevSecOps. I hope it's not overwhelming for you. It's by far it looks like only 12 or 15, 13 different things is what we need to learn, but it's a lot. And I can speak from experience. It's been about 6 years that I'm working in this field, and it is really heavy. So once you get to understand the basics, then everything is easy. It's just the matter of about the usage of tool. Rest, the fundamentals are pretty much similar in all of these things. So that's what I would say for now, and that's how we completed the quest of DevSecOps roadmap for now. So, guys, that's it for our today's video. Let me know if you got any insight of how and what things you need to learn as a part of DevSecOps roadmap. And I would always appreciate if you kind of subscribe and save this playlist, as well as watch this from start to end, because we have covered a lot of things. Okay, over here, right from the fundamentals. So you should not skip the first few videos, okay, up to this one. Rest, you can see these are about threat modeling, so different methodologies, different tools. Okay, so do not skip the fundamentals. Okay, so that's it for our today's video. See you guys in some another video. So bye bye till then, keep learning.